Hi, my name's John. Welcome to another Wednesday catch-up video. I'd like to start off by saying a massive thanks to all the people who come to see us at the NEC. It was great to see some viewers come and shook me hand. Had a good bit crack about welding and about machining, all kinds of different things. Basically, we did have a good weekend, and my wife Deborah has been, well, not inundated, but she's had a few people come and say hello and compliment on our abilities of modelling. Once you built that model gas turbine, I've got a steam engine kit coming for her to do, so we're looking forward to getting stuck into that. Today's video is going to be one of my old ones. I didn't realise, but on my YouTube page it's got videos, it's got current, it's got favourite, and it's got oldest. If you go into oldest, there's some belters in there, really old ones. I've chosen one, in the popular ones, it's turning between centres, fabricating and turning the crankshaft. I hope you find that interesting. I just haven't been in the workshop since I got back from the NEC. Right now for the last shrinking operation, which is that one into there. I've got a bit of nice thick aluminium plate, which when I put it together, that'll lie on the end. Hopefully the crank will stop nice and square. That still is a good fit in there anyway. I'm going to shrink this again with a carbon dioxide and use the propane on the other bit. More ice than that in there. Like the extinguishers eventually. Right. That's quite well cooled off in there now. Next thing is to warm the end of this up and then shrink them together. I've got gloves and I've got tongs and various bits and pieces. About ready now. Moment of truth. Come on, you bastard. That's got it. It hasn't gone right in. Bollocks. As you can see, I've got a face plate mounted onto the lathe. I want to do some turn between centres. Ideally you would use a catch plate for this. I did have two catch plates for this lathe. One I machined into a back plate for a 4-jaw chuck, and that back plate wasn't an L00 back plate, it was an L0 back plate, which I gave away. So now I haven't got a catch plate. But what I have got is a face plate which will do the job just as well. Need to make sure this taper in here is nice and clean. Before we start. No rags or burrs or nothing nasty up there.
Next thing is an adapter. It goes from whatever taper that is to almost taper 3. That goes in. Now I have got a what they call a dead centre. This is a dead centre because it's soft. Goes in that end. But what I'm going to do to make it super accurate, I'm going to make my own. This is the end of a 1/164th inch drill. Any taper shank drills where the tapers are half decent, I buy car boot sales, because this part of the drill is really good material, but it's also soft, so you can machine it. So I'm going to use that to turn the centre out of. You can just put that centre on the forge-jaw chuck, but using a faceplate like this brings everything closer to the spindle of the lathe. Make sure it's home, I don't want it moving. So I'm going to cut this at 30 degrees, which will give us the 60-degree angle we need for the lathe centre. I don't think I've had that faceplate on. In fact, I've never used the faceplate before. Interesting to see how true it runs. Certainly looks true. See how soft that part of the drill is. Just going to speed things up a little bit. Ideally these should be brown to a finished point. Give it one more. Right, that'll do. The last time we saw this was when I did the shrink fit, that one there, and it didn't go all the way home. What I did was I took it to work and we have a 25 ton press at work, and it took all 25 ton of the presser's ability to push that together. Anyway, I have pushed it together, so that's fine now. I lined it to webs up on the surface plate, and I welded it back together again. I've also put it in the milling machine and knocked the big welds off with a milling cutter, just to save the interrupted cuts on the lathe between centres. Machining between centres is a very accurate way to machine. It's an old school method, but it still works fine. The beauty of it is you can take it out of here and swap it over end to end, machine each end separately. You can take it out of here, do anything you like with it and put it back in, and you know for a fact that running between centres, it's going to be running true. The crank's reasonably straight. I've had a clock gauge on as I would a 10 thou run out, which is nothing when you think how it's actually being assembled. Obviously we need a method to drive it. For that we use a drive dog. I'll show you how that works now. This is the drive dog I'm going to use, a nice big meaty old-fashioned thing it is. I'll put the tailstock centre in just to hold it. Right, the idea is when the plate comes round, it hits the drive dog like that, and that's what turns the workpiece round. Well, if you look at this, it's quite a long way out of balance. That's the heaviest part of the drive dog, so I'm going to put that opposite the crank pin, which will help to balance it up somewhat. Obviously when we get this down to finished size, we'll need to put some aluminium packing around here. So we're doing the shaft with a securing bolt. Right, so that comes round and that's what drives it. What I'm going to do is just put a cable tie around here, just so there's no chance of it slopping about and rattling back and forward. One thing you need to be aware of, obviously you've got these big parts rotating, you don't want to be getting caught in there. You'd only get caught in this once, so no jewellery, no sleeves, no watches, no nothing. This crank's quite strong, it's quite stiff, but if I was to tighten that tailstock up, it'll bend the crank. It'll definitely squash that together, which means when you come to take it out from between centres, these shafts won't be straight anymore. So we need to put a piece in there to stop this from happening. I'm just going to use a nut and bolt just to put a little bit of pressure. Right, that's hardly any weight on there, and if I tighten the tailstock, you feel it starting to grip. You've got to be careful how much weight you put on the tailstock as well, because when you machine this, it's bound to get hot and expand. And you've got to keep adjusting the tailstock centre. At least this is a live centre, so a rotating centre. At one time they used to use a solid centre, and they would put white lead and tallow in there to lubricate it. Right, I'll power it up. I won't be able to run this very fast because it is out of balance. Right, as you can see, it's running reasonably true. Quite happy with that. Right, I've taken a light cut off that side. What I'm going to do now is turn it over and take a cut off this side. Once again, I'm going to put the heavy part of the drive dog opposite the big end, which is there. Right, so it's put a nice light cut down there. What I need to do now is measure this end to end to see how much tape is in it. Right, we'll do this in inches because it's easier for me to visualise. I've got 150 eighth thou there. I've got 150 7.5. So there's half a thou taper in that shaft. Half a thou and 6 inches is not bad. It's not perfect, but I think it'll be good enough for a steam engine. It's actually less than half a thou. Right, as you can no doubt see, I put the coolant on. The shaft was getting warm and it's hard to control the pressure on the centres. So just a little trickle of white water, I'll keep it nice and cool to also get a better finish. A bit of blood in with it there as well. Not good. Blood stops play. I suppose at least it was clean stainless. That was just pulling the chip out from the bottom. I should know better. I keep saying do it, but I did it. But the chips are actually breaking now into more manageable bits. Right, it's getting me out of size now, so I've put a nice light cut on just to see what sort of finish I can get. And as normal with stainless, it is a really good finish. So basically now we are at 1 inch 25, and this end is 1 inch 25.5. Just on a half a thou taper in the end, I'm happy with that. I'll flip it over and take some off that side now. See how simple it is to swap ends. Once again, the heavy part of the dog opposite the big end. See, the next time we turn this over, we'll be getting down to size and we'll have to put some protection on here to stop the blood from digging into the shaft. This is a really well dried dog. I think I picked it up at a car boot sale. It's probably seen quite a lot of work. The only problem with stainless with taking light cuts, because you can't really take a heavy cut the way this is mounted. You get these horrible nasty stringy chips. Sharp they are as well.
Hi, I hope you're all well and enjoying the weather wherever you are. This came in the post for me. Well, message for John and for me. This is from Keith Goodwin. So thank you very much, Keith Goodwin. Whoops.
You meant to say a bastard.
You want to start again?
No.
And don't swear like you. Okay. Oops. Oh, I'm in it. It's like Christmas. Oh. Oh wow. Oh wow. Lovely. Bookmarks. Thank you very much, Keith. You're a champion. We will use them on the airplane.
Once again, just time to say thanks for watching, thanks for subscribing, and I am going to keep banging on about mental health. I mean, I've just been to the doctors today for a review. Doctor's happy with us, I'm happy with us. I've been happier, but I'm a lot better than I was. It is vitally important, lads and lasses, if you have a problem or an issue with mental health, you get help, seek help, talk to somebody. Please don't bottle it up. Anyway, thanks for watching.